Okay, and the final little video is just one to show you how to use Maxima to compute eigenvalues and eigenvectors. Okay, so here is a file which you can download from Blackboard. So the first line, I am just defining a matrix called A. Call it whatever you like. So the command is matrix, and then you see that it's just a vector of vectors. Okay, so each of those vectors is a row vector. The first is the first row, the second row, the third row. And then the next command, so that defines A, and then the next command is eigenvectors of A, and that computes the eigenvalues and eigenvectors of the matrix. So here I've already evaluated the cells, and so here is 1, 1, 0, minus 2, minus 1, 3, 0, 0, 2, just as we've defined them up here. And the answer here, this is kind of like a matrix which is generated by eigenvectors A. So the first vector gives us the eigenvalues of A. So we see it's minus I2. And if we add them up, we see we get 2, and we add up the main diagonal, the trace, we get 2. So, okay, that's believable. The second vector, 1, 1, 1, gives us the multiplicities of the eigenvalues. So it says that everything has multiplicity 1. And then the third, fourth, and fifth vectors are the corresponding eigenvectors. So this 1 minus I minus 1, 0, that is the eigenvector for minus I, the first named eigenvalue. And then we have 1I minus 1, 0. That's the eigenvector for I. And notice that minus I and I are complex conjugates, and the eigenvectors are complex conjugate. That's always going to be the case. And then finally, we have the eigenvector 1, 1, 5/3, and that is the eigenvector for 2. Okay, so I hope that helps you in your, if you need to use Maxima to compute, especially if we've got some kind of complicated matrix.